Top 25 Data Analyst Interview Questions and Answers. Preparing for a data analyst interview can be challenging, especially with the ever-evolving tools and methodologies in data science. This guide covers the top 25 most commonly asked interview questions with concise, thoughtful answers to help you confidently demonstrate your technical skills, problem-solving ability, and business acumen in your next interview. 1. What is the role of a data analyst? A data analyst is responsible for collecting, processing, and analyzing data to extract meaningful insights that support decision-making. They work with structured and unstructured data, build reports and dashboards, and help stakeholders understand trends and performance metrics. Key responsibilities include data cleaning, transforming data, using statistical tools, and interpreting results. Analysts often use tools like Excel, SQL, Python, R, and visualization platforms such as Tableau or Power BI. They must also communicate findings clearly to both technical and non-technical audiences. Ultimately, their work helps businesses make data-driven decisions and optimize operations across departments such as marketing, finance, operations, and product development. 2. How do you handle missing or corrupted data? Handling missing or corrupted data involves several steps. First, identify the extent and pattern of missing values using profiling techniques. If the missing data is minimal, you might remove the affected rows or columns. For more critical cases, imputation methods like mean, median, mode, or predictive modeling, e.g., KNN, regression, can fill gaps. In categorical data, missing values may be replaced with the most frequent category or a new, unknown, category. Outlier detection also helps catch corrupted data. Always document the treatment for transparency. It's crucial to assess how each method affects data quality and analysis outcomes before finalizing any approach. 3. What is the difference between data mining and data analysis? Data mining is the process of discovering patterns and relationships in large datasets using algorithms, machine learning, and statistical models. It's more exploratory and often used to predict future trends or classify data. Data analysis, on the other hand, focuses on examining data to extract insights, answer specific questions, and support decision-making. While data mining may uncover hidden patterns, data analysis validates known hypotheses and delivers actionable insights. Data mining is usually a subset of data analysis in complex scenarios. Analysts typically use tools like Python, R, or SQL for analysis and specialized tools like RapidMiner or Weka for mining. 4. What is the difference between structured and unstructured data? Structured data refers to information organized in predefined formats, such as tables with rows and columns, e.g., SQL databases, spreadsheets. It's easy to search, filter, and analyze using traditional tools. Unstructured data lacks a defined schema and includes formats like emails, PDFs, videos, images, and social media posts. It requires advanced processing techniques like natural language processing, NLP, computer vision, or machine learning for interpretation. Semi-structured data, such as JSON or XML, lies between the two. As a data analyst, understanding both types is critical, as modern data environments often combine structured and unstructured sources for comprehensive analysis. 5. What tools and software do data analysts commonly use? Data analysts typically use a range of tools for data processing, analysis, and visualization. For querying and managing data, SQL is a foundational skill. Python and R are used for more advanced data manipulation, statistical analysis, and machine learning. Microsoft Excel remains popular for quick analysis and reporting. For data visualization, tools like Tableau, Power BI, and Looker are widely used to create dashboards and reports. Analysts also use Google Sheets for collaborative work and Jupyter Notebooks for code-based presentations. For big data or cloud-based environments, familiarity with tools like Google BigQuery, AWS Redshift, and Snowflake is valuable. 6. What is data cleaning, and why is it important? Data cleaning involves identifying and correcting errors or inconsistencies in datasets to improve their quality. This includes handling missing values, removing duplicates, correcting inaccuracies, and standardizing formats. Clean data ensures accurate analysis, leading to reliable insights. Without it, models and reports can be misleading or flawed. Data cleaning also involves validating data types, removing irrelevant data, and ensuring consistency across datasets. It's often the most time-consuming step in data analysis but arguably the most critical. Effective cleaning reduces noise, enhances model performance, and ensures that decisions based on the data are trustworthy. Clean, well-prepared data is the foundation of sound analytics. 7. What is the difference between INNERJOIN and LEFTJOIN in SQL? An inner join returns records that have matching values in both tables involved in the join. If there's no match, the record is excluded from the result. In contrast, a left join returns all records from the left table and matched records from the right table. If there is no match, the result contains NULLS for columns from the right table. Left join is useful when you want to keep all entries from the left dataset regardless of matching values in the right one. Understanding these joins is crucial for combining datasets and retrieving meaningful relationships across multiple data sources. 8. How do you approach a new data analysis project? A successful data analysis project begins with understanding the business objective or problem. Then, I gather relevant data, assess its quality, and clean it to prepare for analysis. After exploratory data analysis, EDA, I identify trends, patterns, or outliers. I choose appropriate methods or models based on the objective, be it descriptive analysis, forecasting, or segmentation. I document my process, use visualizations to explain key findings, and present results in a way that's actionable for stakeholders. Throughout, I ensure the analysis aligns with the business goal. Regular feedback and iteration also help refine the analysis for better accuracy and impact. 9. What is normalization? Why is it important? Normalization is the process of organizing data to reduce redundancy and improve data integrity. In relational databases, it involves decomposing tables into smaller, related tables and defining relationships using foreign keys. This ensures that data is stored logically and consistently. Normalization minimizes anomalies in insert, update, or delete operations. In analytics, normalization can also refer to scaling numeric data to a common range, e.g., 0 to 1, for modeling purposes. This is especially important in machine learning, where unscaled features can skew results. Both types of normalization help maintain quality, improve performance, and ensure reliable insights in data analysis workflows. 10. Explain the difference between variance and standard deviation. Variance and standard deviation both measure the spread of data values around the mean. Variance is the average of the squared differences from the mean, showing how much values deviate overall. Standard deviation is the square root of variance, offering a more interpretable value in the original data units. A high variance or standard deviation indicates data points are spread out. Low values suggest they are clustered closely. Standard deviation is often preferred because it is easier to relate to real-world values. Both are essential in understanding data distribution, detecting outliers, and assessing variability in data-driven decision-making. 11. What is a pivot table, and how do you use it? A pivot table is a powerful Excel and data visualization tool used to summarize, analyze, and explore data interactively. It allows users to group data by categories, calculate aggregates like sums or averages, and identify trends. For example, you can create a pivot table to display total sales by product category and region. Pivot tables are especially helpful for dynamic reporting and quick insights without complex formulas. You can drag and drop fields into rows, columns, values, and filters to restructure data instantly. In analytics, pivot tables are a fast and accessible method for slicing and dicing large datasets. 12. What are outliers, and how do you deal with them? Outliers are data points that significantly deviate from other observations in a dataset. They can arise due to data entry errors, measurement inaccuracies, or natural variability. Identifying them involves visualization, e.g., box plots, scatter plots, and statistical techniques like the z-score or IQR method. Once identified, outliers can be removed, capped, or treated depending on their cause and impact on analysis. In predictive modeling, untreated outliers may distort model performance. However, outliers may also represent valuable signals, e.g., fraud detection, so they shouldn't be automatically discarded. Analysts must evaluate context and objectives before deciding how to handle them appropriately. 13. What is the difference between correlation and causation? Correlation is a statistical measure that describes the strength and direction of a relationship between two variables. Causation indicates that one variable directly affects another. While two variables can be correlated, it doesn't imply one causes the other. This is a common analytical fallacy. For example, ice cream sales and drowning incidents may correlate due to summer weather, not because one causes the other. Establishing causation often requires controlled experiments or statistical models that account for confounding variables. Data analysts must be cautious when interpreting correlations and avoid misleading stakeholders by implying causal relationships without sufficient evidence. 14. What is A/B testing? A/B testing, or split testing, is an experimental approach to compare two versions of a variable, A and B, to determine which performs better. It's commonly used in marketing, product design, and user experience optimization. For example, two web page versions might be tested to see which has a higher conversion rate. Key metrics are tracked, and statistical significance is assessed to ensure the result isn't due to chance. A/B testing requires proper randomization and sample size to be valid. It helps organizations make data-driven decisions by testing hypotheses in real-world scenarios with minimal risk. 15. What is the difference between a clustered and a non-clustered index in SQL? A clustered index determines the physical order of data in a table. Each table can have only one clustered index because the rows are stored in that order. Think of it like a phone book sorted by last name. A non-clustered index, on the other hand, stores a separate structure with pointers to the actual data, allowing multiple indexes per table. It's like a book index that directs you to the correct page. Clustered indexes are faster for range queries, while non-clustered ones are better for searching specific columns not included in the clustered index. Both improve query performance significantly. 16. Describe the steps of an ETL process. ETL stands for extract, transform, load, a process used to move data from source systems into a data warehouse. Extract. Data is pulled from various sources like databases, APIs, or flat files. Transform. The data is cleaned, filtered, enriched, and formatted to match business logic and schema. This may include joins, deduplication, data type conversion, or aggregation. Load. The processed data is loaded into a destination like a data warehouse or database for analysis. ETL ensures consistency, quality, and reliability across datasets, forming the foundation for reporting, dashboarding, and advanced analytics in modern data systems. 17. What is the difference between supervised and unsupervised learning? Supervised learning involves labeled datasets, where the algorithm learns from input-output pairs, e.g., predicting house prices based on features. Common methods include linear regression, decision trees, and classification models. Unsupervised learning works within labeled data, aiming to uncover hidden patterns or groupings, e.g., customer segmentation. Techniques include clustering, k-means, DBSCAN, and dimensionality reduction, PCA. Supervised learning is used for prediction and classification tasks, while unsupervised is for exploration and insight. As a data analyst, knowing both helps choose the right modeling strategy depending on whether the outcome variable is known or unknown. 18. What are KPIs and how do you define them in a business context? Key performance indicators, KPIs, are quantifiable metrics that reflect how effectively a company or team is achieving its strategic objectives. Defining good KPIs involves aligning them with business goals, ensuring they are specific, measurable, achievable, relevant, and time-bound, SMART. Examples include customer acquisition cost, churn rate, net profit margin, or website conversion rate. As a data analyst, your job is to collaborate with stakeholders to define, calculate, and monitor these KPIs using accurate data and visual dashboards. KPIs help organizations track progress, identify issues, and make data-driven decisions to improve overall performance across departments. 19. How do you validate the accuracy of your analysis? Validating analysis starts with data quality checks, ensuring there are no duplicates, missing values, or inconsistencies. Next, I use descriptive statistics to understand distributions and compare them with expectations. I also apply cross-validation or split datasets into training, testing sets for predictive models. I seek peer reviews to catch blind spots and often compare multiple methods to check if findings are consistent. Outlier and sensitivity analysis help assess if small changes drastically alter results. Finally, I communicate with stakeholders to confirm the analysis aligns with business realities. Validation is key to building trust and ensuring reliable insights. 20. What is regression analysis and when would you use it? Regression analysis is a statistical method used to model the relationship between a dependent variable and one or more independent variables. It helps predict outcomes and understand how variables influence each other. For example, you can use regression to forecast sales based on advertising spend, or determine how temperature affects ice cream sales. Types include linear, multiple, logistic, and polynomial regression. Regression is widely used in forecasting, budgeting, and performance modeling. As a data analyst, regression provides not just predictions but insight into how strongly factors contribute to results, guiding strategic decision-making. 21. How do you communicate your findings to non-technical stakeholders? Effective communication starts with understanding the audience's goals. I simplify complex concepts using clear language, avoiding technical jargon. Visualizations, charts, graphs, dashboards play a key role in telling a compelling story with the data. I structure my presentation with context, key findings, and recommended actions. Using analogies and real-world examples helps make insights relatable. I also prepare for questions and tailor the message to each stakeholder group. Executives might need high-level summaries, while managers want operational detail. The goal is to drive understanding and action, not just report numbers. Good communication is as critical as the analysis itself. 22. What is a time series analysis? Time series analysis involves studying data points collected or recorded at specific time intervals to identify trends, seasonal patterns, and potential forecasts. Examples include stock prices, sales data, weather reports, or website traffic. Analysts use techniques like moving averages, decomposition, and ARIMA models to analyze time-based behavior. Time series analysis is essential for understanding how data evolves and for making future predictions. It helps organizations anticipate demand, detect anomalies, or adjust strategies based on cyclical patterns. Analysts must account for trends, seasonality, and irregular components to extract meaningful insights from time-dependent data. 23. What is the difference between OLAP and OLTP? OLTP, online transaction processing, systems are optimized for handling day-to-day transactional operations like order entry, payments, or customer data management. They are designed for high-speed insert, update, and delete operations. OLAP, online analytical processing, systems are optimized for complex queries and analysis, such as data aggregation, reporting, and multidimensional analysis. OLAP systems often use data warehouses and support decision-making. In short, OLTP is about capturing data efficiently, while OLAP is about analyzing it effectively. As a data analyst, OLAP tools are essential for slicing and dicing large datasets to uncover strategic insights. 24. What is a dashboard, and how do you design a good one? A dashboard is a visual interface that displays key metrics and trends in an easily digestible format. A good dashboard provides real-time, actionable insights tailored to the audience. Effective dashboards are clear and uncluttered, visually engaging with appropriate charts, interactive, allowing users to filter or drill down, goal-driven, aligned with business objectives, updated automatically, avoiding manual refreshes. Popular tools include Tableau, Power BI, and Looker. A well-designed dashboard tells a story with the data, helping decision-makers track KPIs, identify issues, and act swiftly based on insights. 25. How do you stay updated with the latest tools and trends in data analysis? I stay current by subscribing to industry blogs, newsletters, and platforms like Towards Data Science, KD Nuggets, and Analytics Vidya. I also take online courses, Coursera, Udemy, LinkedIn Learning, attend webinars, and participate in forums like Stack Overflow and Reddit. Engaging with real-world projects, following thought leaders on LinkedIn, and experimenting with new tools like dbt, Snowflake, or newer Python libraries keeps my skills sharp. I often join local data communities or attend meetups for networking and idea exchange. Staying updated is essential, as the field of data analytics evolves rapidly with emerging technologies and best practices. Mastering these 25 questions will give you a strong edge in your data analyst interviews. Focus on understanding the why behind each concept, not just memorizing definitions. Keep practicing real-world problems and stay curious. The more confident you are with the data, the more valuable you'll be to any organization.